So one thing that you should really make sure you see here is that they don't tell you the masses of these objects. They tell you the weights, right? So what they're actually telling you is the force of gravity equals, for the first one is 51.5 newtons. The force of gravity for the second object is 33 newtons. And the force of gravity for the third object is 25.6 newtons. So I've labeled them on here. If there was no string here, if these two boxes were not like these two boxes, if they were just all alone, let's just draw a picture of those two alone. So if I was to draw a free body diagram of those two boxes, it would be, let's see, it would be 51.5 plus 33. So you'd have an 84.5 Newton block, and you'd have gravity, which is Fg, which is that number, 84.5 newtons. You'd also have the normal force, Fn, acting up. And if there was nothing going on, the normal force would equal the force of gravity. But you do have something going on. You have this tension due to the 25.6 kilogram block. Okay, so in order to figure out what tension is, we want to know what this is, right? So that we can use it, like what we're ultimately trying to do here is get an Fnet statement. Fnet equals the sum of the forces, which equals Ma. Sum of the forces is going to be Fn plus T minus 84.5 equals 84.5A. So this is what we're, oh no, sorry, that's wrong. It's not 84.5A. It's equal to MA. So in order to find M, we have to take this. So this is the force of gravity, right? Equals MA. So 84.5 equals MA, or sorry, MG. So then we can just find the mass by saying 84.5 divided by G. So whatever that is, 84.5 divided by 9.8 divided by 9.8 equals, so it's like 8.62. So the mass here is 8.62 kilograms. So just, that's one of the things you have to sort of, that one of the tricks that you can get stuck with in this problem is the difference between weight and mass. So while they give you the weight, you do actually need to know the mass. So we had to calculate that. All right, so in order to solve this problem, which is asking for the normal force, I need to first solve for tension. So I'm going to go to my second free body diagram, which is of the 25.6 kilogram block. And I can see that that same tension force is going to act on it. It's an action reaction, right? So the rope just conveys the tension. And then this is going to have the force of gravity, which I know is 25.6 newtons. Now, the thing with this is that it's at rest, so A equals 0. So actually the tension is really easy to calculate. It's just going to equal. So from this, we can see that T just equals 25.6 newtons. So now we can take this number, let's see, take that number, plug it into there, and we can find the normal force.